M1 Dynamics example 10. In this example, we've got an object, a particle, which is being held on an inclined plane. And a lot of exam questions involve this idea of an inclined plane. So it tells us that the plane is inclined at an angle alpha, and alpha is 0.75. Tan alpha is 0.75. We know that's 3/4. And so if you look back at example 9, you'll remember that we can work out the values of sine and cos alpha quite easily. So tan is opposite over adjacent, and so the third side of the hypotenuse will be 5. Therefore, sine alpha, opposite over hypotenuse, will be 3/5, and cos alpha, adjacent over hypotenuse, will be 4/5. So let's have a look at this particle. We've got a particle held at rest on a rough plane. The coefficient of friction is 0.5. So let's make a note of that. Let's have a look at the forces. There's always a normal reaction, and that acts at right angles to the surface that the object is resting on. We know that the weight will act vertically downwards. In this case, we don't actually know the weight, so if I call the mass m, the weight would be mg. We know that there's friction, and if you read ahead, it says the particle is released and it slides down the plane. So it's going to accelerate that way down the plane towards the left, and so friction will resist the motion, so that will act up the plane. So they're the only forces, and there's nothing pulling it down the plane apart from the effect of this force of gravity. Now, if we think about what's happening with the angles here, suppose this angle was, say, 30. We'd have a right angle down here at the bottom corner, and so this top angle here would be 60. If I then draw in another line here, following down from that normal reaction, we've got another right angle here. If that was 60 at the top, this angle here will be 30. In other words, it would be the same as this angle at the bottom, and that's always true. The angle between the weight and the vertical is always the same as the angle at the bottom. So if this was 40, the one at the top here would be 50, and then because we have another right angle, if that was 50, this would be 40. So you can always work out that this angle here is the same as the one at the bottom. So rather than resolving vertically and horizontally, we're going to resolve, first of all, perpendicular to the plane. Now we know that it's not moving up and down off the plane, so forces upwards, which is R, will equal the force downwards. Now, that mg is vertically down, and we want to resolve it so it's perpendicular to the plane. So it would be mg cos of alpha, because you're turning through the angle alpha. Now we know that cos alpha is 4/5, so R is 4/5 mg. If we now resolve parallel to the plane, going in the direction of motion, doing F equals ma, we'll have mg sine alpha, because we're turning away from the angle, minus the friction, because that's a resistive force. So you've got mg sine alpha pulling it down the plane, F resisting motion, and that will be equal to the mass times the acceleration. Now, because it's moving, we know the friction is at its maximum, so F will be equal to mu r. We know that mu is a half, we're told that in the question, and r is 4/5 mg. So the frictional force is half of 4/5, which is 2/5 mg. So we can substitute that friction into this equation. Mg sine alpha is 3/5. So that's the first part. Subtract the friction, which is 2/5 mg, and that will be equal to ma. So if I go through and cancel out the m's, we'll end up with 1/5 of g equals a, and that's the answer. So 1/5 of g, that works out to be 9.8 over 5, so that's 1.96. So that's the first part of the question done. Find the acceleration of the particle. We've now got to work out how far it slides in the first 2 seconds. So think about what we know. It's accelerating along the plane with an acceleration of 1.96. We know that it's going for 2 seconds. We know that the initial speed was 0. And we've got to work out how far the particle goes. So this is a kinematics question. Looking at the variables involved, I would use s equals ut plus a half a t squared. So u is 0, and then it's a half times a times t squared. So working all that out, it works out to be 3.92, but because we're working to two significant figures, 3.9 meters is the distance.